Naming ionic compounds can seem difficult at first, but there's really only a couple rules that you need to follow. First off, before you try naming an ionic compound, you should identify that it is an ionic compound. So first thing you want to do is make sure that you have a metal bonded with a non-metal. So to do that, you got to remember which are the metals, which are the non-metals. So everything over here is going to be a metal. All of these metals, most of the periodic table is a metal. When we talk about non-metals, non-metals are only this little corner up here. So we're really only doing nitrogen, phosphorus, oxygen, sulfur, selenium, fluorine, chlorine, bromide, and iodine. So we're going to have one of these 9 bonded with one of the rest. Now, it's really easy if we're doing non-transition metals. So that's any of these or aluminum bonded to one of these pink ones. Okay? So let's go about how we do that. First off, the number one rule is you always write the metal's name. No matter what, you always start with the metal's name. There's no prefix, just the metal's name. Then, if you've just got one of the ones that's in the green here or the pink here, all you have to do is write the name of the non-metal ending in "ide." So nitrogen becomes nitride, oxygen becomes oxide, fluorine becomes fluoride, phosphorus becomes phosphide, sulfur becomes sulfide, chlorine becomes chloride, selenium becomes seleniide, bromine becomes bromide, and iodine becomes iodide. So we can take any two of these. So if we take one from the green, one from the pink, we can just go potassium is going to be K. And then if we bond that with sulfur, that would be K2S, because remember sulfur is a -2, K is a plus. So we need 2 pluses to make this neutral. We would just call this potassium sulfide. So we start with the metal's name. Metal's always going to be written first. Non-metal's always going to be written second. Potassium sulfide. That's all there is to it. It's a lot harder to go the other way. So if we're starting with the things named, so if we do, for instance, calcium phosphide, if you're given that and you have to come up with a formula, there's only one formula that's calcium phosphide. So to do that, what you got to do is you look for where calcium is. Calcium's in the second group here, so it's going to be a +2 ion. It's going to form a +2 ion. Phosphorus is 3 over from the noble gases, so it's going to be a -3 ion. Then we can just cross, and we get Ca3P2. That's calcium phosphide. Now, these become a lot more confusing if you have a transition metal. Now, if there's a transition metal, now instead of having just one ion that it can form, many of them can form several. So what you have to do is you have to find the metal's ionization number. So to do that, you have to know what the formula is. So if you're given
Chip on, please call the front office, star 1003.
PB2O. That means we have 2 leads. Oh wait, no, I'm sorry. PbO2. My mistake. So Pb is lead. So we're going to write lead. O2 is oxide. We almost are done. We just have to figure out what goes in the parentheses here. Now, oxide. Every oxide is going to be a -2 ion. We've got 2 of them. So 2 times -2 is -4. So we need to have a +4 up here. So this is going to be, and we use Roman numerals, lead 4 oxide. Okay? Let's do another one since I know these are the harder ones. If we did, let's find a good one. If we had tin, Cl2, so SnCl2, every Cl is a -1. We've got 2 -1s, so that means this has to be a +2. This whole compound has to end up being neutral. So we've got 2 here, or +2, and then 2 -1s. Gets you 0. So when you work that out, that's going to be tin 2, the 2 comes down like that, chloride.